Hello students, welcome in your classical mechanics class. In this lecture we will talk about elastic scattering in laboratory system. First we look at the laboratory system. Laboratory system is a coordinate frame fixed with respect to the laboratory. It's convenient if we choose the corner as the frame of reference in your laboratory. So we consider the case of one-dimensional collision. We consider that along the x-axis particle 1 having mass m1 is moving with velocity u1 along the x-axis, and particle 2 having mass m2 is at rest, so its velocity is 0. Now, after the collision, the particle 1 scatters at an angle alpha with respect to x-axis and moves with velocity v1, and the target particle, that is particle 2, recoils at an angle beta with respect to x-axis and moves with velocity v2 in this xy plane. So if we choose y-axis and j cap is unit vector along y-axis and I cap is unit vector along x-axis, then along this direction axis is negative y-axis. So as we know, in case of elastic scattering, linear momentum and the kinetic energy of system is conserved. That means the linear momentum of the system before the collision is equal to linear momentum of the system after the collision. So from law of conservation of linear momentum, we have m1 u1 plus m2 u2. u2 is the velocity of second particle, which is 0 in this case, so I write it 0, is equal to m1 v1 plus m2 v2. Now this velocity u1 is along the x-axis, so we can write it as m1 magnitude u1 into unit vector I cap along the x-axis is equal to m1. Now v1 is in the xy plane, so it is better to write it in terms of component I cap and j cap. So I will write it as v1 cos alpha I cap plus v1 sin alpha j cap plus m2, and velocity v2 in term of component I cap and j cap is v2 cos beta I cap minus v2 sin beta j cap. Why I write negative sign? Because now it is along the negative y-axis. So by comparing the component of I cap and j cap on both sides, we have m1 u1 from the component of I cap is equal to m1 v1 cos alpha plus m2 v2 cos beta, and from the component of j cap we have 0 is equal to m1 v1 sin alpha minus m2 v2 sin beta. So we have, let it be equation number 1, 2 and 3. Now from law of conservation of kinetic energy, the kinetic energy of the system before the collision is equal to kinetic energy of the system after the collision. So kinetic energy of the system before the collision is half m1 u1 square plus half m2, velocity of second particle is 0, is equal to half m1 v1 square plus half m2 v2 square. So this is equation number 4, and from this equation we have m1 u1 square equal to m1 v1 square plus m2 v2 square is, let it be equation number 5. So now we have equation number 2, 3 and 5 with 4 unknown constants alpha, beta, v1 and v2. So from these three equations it is difficult to find out the four unknown constants, so it is convenient to consider that the particle 1 and 2 having equal mass, so we consider that m1 is equal to m2 is equal to m. This is for the simplicity, so from equation 2 we can write it as u1 is equal to v1 cos alpha plus v2 cos beta. M is common, and from 3 we have v0 is equal to v1 sin alpha minus v2 sin beta, and from equation 5 we have u1 square is equal to v1 square plus v2 square. So this is equation number 6, 7 and 8. Now we will rearrange these equations to simplify and get the solution. So we write it as equation number 6 as u1 minus v1 cos alpha is equal to v2 cos beta. So let it be equation number 9, and equation 7 can be written as v1 sin alpha is equal to v2 sin beta. So this is equation number 10, and from equation 8 we can write u1 square minus v1 square is equal to v2 square. So this is equation number 11. Now squaring equation 9 and squaring equation 10 and adding these two equations, we have u1 square plus v1 square cos square alpha minus 2 u1 v1 cos alpha plus v1 square sin square alpha is equal to v2 square cos square beta plus v2 square sin square beta. So we have u1 square plus v1 square from this and this equation, sin square alpha plus cos square alpha equal to 1 minus 2 u1 v1 cos alpha is equal to, from here we have v2 square. So let it be equation number 12, and from equation 10 we have from equation 11 we have v1 square u1 square minus v1 square equal to v2 square. So this is equation number 13. We have from equation number 13 and 12 we have u1 square plus v1 square minus 2 u1 v1 cos alpha is equal to, we have u1 square minus v1 square. So from here this term is cancelled, so it is 2 v1 square is equal to 2 u1 v1 cos alpha. From here we get v1 equal to u1 cos alpha. So we get v1 is equal to u1 cos alpha. Now from equation 11 we have u1 square, we will substitute u1 square minus v1 as u1 cos alpha whole square equal to v2 square. So from here we get u1 square common 1 minus cos square alpha equal to v2 square. So it is u1 square sin square alpha is equal to v2 square. From here we have v2 equal to u1 sin alpha. So we have two expressions, v1 equal to u1 cos alpha and v2 equal to u1 sin alpha. That means v1 and v2 are in term of alpha and u1. Now from equation 10 we have v1 sin alpha equal to v2 sin beta. So we will substitute v1 and v2 from these two equations. Here in equation 10 it is v1 is u1 cos alpha sin alpha as it is, sin alpha is equal to v2 is u1 sin alpha and sin beta as it is. So u1 is cancelled, sin alpha is cancelled, so we have cos alpha equal to sin beta. So this is possible if cos alpha sin beta is equal to sin 90 minus alpha, because sin 90 minus alpha is cos alpha. So I can write it as beta is equal to 90 minus alpha. So you can write alpha plus beta equal to 90 degree. So that means angle alpha plus beta equal to 90 degree. That means this angle, this total angle is 90 degree. So that means the particle 1 and 2, if the mass of the particle 1 and 2 is same and the particle 2 is at rest, then the two particles move at right angle to each other after the collision. So that means they scatter at 90 degree with respect to each other. In case of elastic scattering in a lab system, the condition is the particle 2 is at rest and the mass of the two particle is same. That means m1 is equal to m2 is equal to m, as we consider in this example. So in the next lecture we will talk about the elastic scattering in center of mass system. So center of mass system is the system in which we consider that the coordinate system is fixed with respect to the center of mass. So what is center of mass? You can go through the previous lectures on the center of mass, concept of center of mass. Thank you for watching.